Okay, I'm going to clear the screen. Let's move on to section 6, and I want to show you this example. When there is a number at the beginning of the sed command, that indicates what address we're dealing with. But if we have a number at the end of the sed command, that indicates which match we are dealing with. So we are performing this substitution on the third address, and so this will affect 33 rather than 11 and 22. Okay, let me demonstrate again with the second address. So the second line will be affected, or the first. I'm going to clear the screen again, and that's one way. The address is one way of indicating which pattern. Here we have a pattern and we have an action. So at this pattern, so beginning the line beginning with the comment character, we are performing this substitution. See how the pattern is the line that begins with 11, and in contrast to this pattern, if you use the backslash as the first character in your pattern statement, and then you put another character afterwards, this indicates that you're using the comma as the delimiter for the pattern. So the backslash indicates the delimiter as the comma, and then we're using comma as the delimiter for the pattern. It's just something that's very interesting I wanted to point out. Now again, we can use the underscore rather than the forward slash, and this is very useful for us. So here, anything that begins with the line with n will have this substitution applied to it. Now you could also have address ranges. So from address 1 to address 2 we want to do this substitution. Here this address range indicates from address 1 to the last address, and again I just want to illustrate here that line numbers are cumulative if several files are edited. So if you're using sed for multiple files, you should know which addresses you're dealing with. So from address 1 to address 2, we want to substitute with the lowercase. Now, this should go for the end of the, so 1 through 9. Oh, if I'd used the dash there. So nine lines. Okay, let's move on to the next subject. I'm going to clear the screen, and again, here's my text. So a lot of diversity here. Here we're specifying anything between begin and end will have these substitutions applied to them. So here's begin and here's end, and we're removing blank lines, actually empty lines and commented lines. Okay, here's the same thing. 2 commented lines and a non-commented line. And so we're saying from address 1 until the begin pattern is found, do these substitutions. So from address 1 until the begin pattern is found, do these substitutions. So you can use patterns and address numbers interchangeably. it depends on how you want to write this. So let me show you this one. And here, so from the pattern end till the last address, we are doing these substitutions. So from end till basically begin. So, well, begin doesn't begin with a comment character. See, the comment character is in between the end and the begin. I'm going to clear the screen. This takes practice to remember. So 1, 2, and 3. And so from address 2 until the last address, we want to delete. So this can be very powerful. So again, this doesn't remove the white space. I just want to demonstrate very quickly. I think I've demonstrated this before. How to remove the white space, how to remove the empty lines, how to remove commented lines, and how to do multiple substitution and or commands with semicolons. Okay, I don't want to reiterate this too much, but using the silent option is very useful. I'm going to clear the screen. Let's take a look at this. And so we are printing the first address. We're printing the pattern one. So we can print from a pattern, or we can indicate the address number and then we can print. So address number 1 is 1. We want to print from address number 1 to address number 2. So we're printing a range of addresses, or you could delete a range of addresses as well to delete these lines from the document. And let's take a look at section 8 here. So here, just want to show you very simply, I'm going to clear the screen, pair, and then I'm printing that pattern. I don't need a space there actually. Okay, and now I'm saying don't print. And so here, don't delete means print, and don't print means delete. The exclamation point in front of these commands will invert their address restriction, and so it's basically opposite day. And I'll explain how that works. This won't print that. This will delete pair rather than print it. So it inverts the address restriction. So sometimes we want to perform an action on each line except those that match a regular expression or outside of a range of addresses. So inverted match is what exclamation point means in this context. Let me show you how that works. Let me echo this, and we have 1 through 20. I'm going to clear the screen. Okay, so now I want to print line 1 through 5. Okay, and now I want to, from line 6 to the last line, I want to not print. So this will by default print the first 5 lines. Now from 1 to 5 I want to not delete, and that will also print lines 1 through 5. Gonna clear the screen. Now from line 11 to the last line I want to delete, so this will print 1 through 10. You can also just delete the first 10 lines, and then you'll be left with 11 through 20. Okay, so which one was the last one? So okay, so here we are from line 11 to the last line, we are not deleting. So we're printing. Yeah, clear the screen again. So from line 6 to the last line, we're printing. And then now we're deleting. So from line 6 to the last line, we are deleting. And then by default, we're printing the first 5 lines. So the exclamation point will invert the address range. Okay, let's get set up for section 9. In this section, I will show you how to use curly braces to group commands and how to nest commands in sed. So let me show you the text. We have a commented line, an empty line, and a line that begins with a space. We can use the E option to specify multiple sed expressions per sed command. Hold on, let me just paste that in there. Use the unnamed pipe. And it removes commented lines and then lines with spaces in them and also empty lines. So I don't have to write it like this. I could write it like this. Just space, backslash, and then I get to continue on to the next line, space, backslash, and the next expression, space, backslash. And then for the last expression, I will leave off the space and the backslash, and then this will execute. But this command excuse me. I was trying to go to the front of it and it would not work. This command is one expression because there is only one pair of quotes, and this starts with a pattern range. So from the pattern begin to the pattern end, there would be a match. And so once the pattern is matched, then the actions will execute. So the substitution commands, this delete command, and this print command. I have it written here in a much shorter fashion because I'm using semicolons to separate the different commands in the curly braces or in the group. I'm going to clear the screen. So again, if I purposely put these characters between begin and end so that they will be matched by the pattern, and so the actions will execute. I'm going to clear the screen. And let's move on to the next example. And here I am using nesting. So here we have between begin and end 2 commented characters. Okay, and so here I have an address range from address 1 to address 3, and then I have curly brace here so that this is all one group. But then I have a pattern specified within this group. Actually, this is a pattern range specified within this group, and then I have another curly brace so that I can put the actions here. So if both the address range and the pattern range are satisfied, then these actions will occur. Let me show you how that works. So begin is the only thing that is left because end occurs at address 4. And so, of course, these two occur at address 2 and address 3. This is at address 1, and these occur between begin and end. That's the shorter version. Okay, let's move on to the next example. I'm going to clear the screen, and now let's take a look at the text. Okay, so I have begin and end. I have 1 through 4 between them, and then I have 5 that is not within that pattern range. And so I have this, and so this will be the pattern range. And remember, when the exclamation point is in the address position for a command or a group of commands, we are specifying the inverse address. So anything that occurs between begin and end will not have these actions applied against them. And also 5 is not there. 5 is not printed because it doesn't match the pattern range. It is out of range of the pattern. So everything between 1 and 4 is affected, but 5 is not. So 5 is not even printed. I'll have some more examples of inverse match. I'm going to clear the screen, and let's take a look at this. Here we have a pattern range, and so if the pattern is found, then the action will execute. Let me put something outside of that range so that you can see that that is not affected. And here's another way of writing this, and yet another way that is more compact. So the next tutorial, I'm going to clear the screen, has to do with another pattern range from A to B. And so this substitution command is going to execute if it falls between A and B. So you can see that the 3 here and the 3 here are affected by this. It's the compact version. Now, if I wanted to skip over one of the strings, let's say I wanted to skip over string A3, I'm just going to use the pattern, and then I'm going to use the lowercase n to append this string into the pattern space, and so it is skipped over, and then the next string will be affected by the substitution, but not the first. Now here we want the third string to also be excluded, so it's also getting a lowercase n, and so only the third string is affected. And you can use the lowercase n as many times as you would like to exclude more and more strings or more and more lines actually down your document. I'm going to clear the screen. And then let's take a look at this example. This example uses the lowercase n here, but now I'm also using the inverse address here to specify that for the pattern B, for anything matching the pattern B, I don't want it to be substituted. But this will affect the middle string because the middle string does not contain B at all. And of course the first string has been appended to the pattern line and has been skipped over. So again, using the inverse of a group of commands, to apply specifically, actually to not apply specifically to a pattern, but apply to the rest of the text. I'm just going to line it up this way. Okay, now let's take a look. I have told you what the write command is before. I'm going to clear the screen here. And here I have a bracket expression that specifies even numbers. The and symbol means the pattern found. So we will take in this text and then we will filter it so that only the even numbers are output. And then we are going to write this output to even.text. Okay, so that's our output. Now I am using the semicolon command, the semicolon, to chain together a lot of echo commands that will echo the values 1 through 12 to file 1 through 12. Okay, and now I'm just going to print this. So basically I'm using files 1 through 12 as input. And then sed is filtering this text using this expression and then replacing the text, and then so it's filtering with this substitution command, and then we are printing that information to the screen. Also, we can use the W command to write this to a file. Okay, so this can be very useful if you need to write a report based upon the text in a lot of files, or if you have a lot of files that have the text specifically that you need, but you need to transform that filter and transform that text, and then send that to another file. You can do that with sed. Okay, now I'm going to move on to show you how to add new lines in sed. So I'm echoing the string 3 to sed3.text, and now I'm specifying that after the pattern 2, I want to read in the contents of this file. So you see, I have it, and now let me echo another string to end.text. So let me echo, is this the end? And then sed will read in the contents of end.text at the last address. Okay, and so that's the R command. Now let me show you the I, A, and C commands. So each one of these uses the backslash right after the command to separate itself from the string that it wants to insert or append or change. So let me show you that I'm echoing word, and then I'm appending word at the pattern word. I'm appending this line underneath it. So the append command appends a string or a series of strings underneath the pattern. So the I will insert above the pattern, and then the C command will actually change the pattern. Here I'm using all 3 of these commands. Okay, and the pattern, the append can last for more than one line. You can add your lines by using the backslash continuation. So here, let me just clear the screen. Here I am appending these lines under word, and now here I am inserting these lines above the word, and now I am changing that word to what I specify. Now, you don't have to use a pattern. You can use an address, or you can use an address range. So the first line, the first address to the last address will be changed into 3. And here's an interesting one. This one will, I'm just going to press enter and then end quote. And so this will single space the lines with empty spaces. So yep, those are empty spaces. I'm just going to clear the screen. And so for the sed loop, the main loop of a sed script looks like this. The next line is read from the input file and placed into the pattern space. The end of the file is found. If there are additional files to read, the current file is closed and the next file is opened. The first line of the new file is placed into the pattern space. The line count for sed is incremented by 1, and opening a new file does not reset this number. All sed commands are examined. The command is executed if there is a restriction placed on the command, and the current line in the pattern space meets that restriction. The N and D commands instruct sed to go to the top of the loop, while the Q command will instruct sed to stop. And when all of these commands are examined, the pattern space is output if the silent option is used to suppress automatic printing. So good to know. That's the main behaviors of sed. So here I am using a pattern to delete, or I could use an address range or a pattern range to delete. So that's good to know. The equals command will output the address number of the match. So here's the pattern range, and this will output the address range. So good to know. You know, this is the last line of the file, and so the address of the last line is 2. The Y command is odd because it is similar to sed, but it transliterates the characters in the pattern space which appear in source to the corresponding character in destination. So like sed, but does not use regular expressions apparently, but I'll have to circle back on that. I'm going to clear the screen. And so the end command will read and append the next line of input into the pattern space unless the silent option is used. But the capital N will read in the next line and append a new line character along with the input line to the pattern space. It uses new line as an anchor character, and in which new line matches a new line character separating lines in the pattern space. So let me show you how that works. Here we have comment character at the end of the file, and this will match at this pattern. Let me print this with the silent option. Okay, so now we have used the capital N command to read both of these into, so this is the pattern, so this will read this into the pattern space, but then the capital N command will read the new line 2 into pattern space as well. So then we can operate on both of those, and then we can use a substitution command that substitutes this with space, thus putting these strings both on the same side, on the same line. So the capital N command is very useful for taking strings that occur on different lines and then putting them on the same line. I'm going to give you another explanation, another example actually. Okay, so here we are matching on the pattern 1, and then the capital N command will save this to the pattern space. And so then we are matching on that and printing, and then 3 will be excluded because 3 was not specified. I'm going to clear the screen again, and let's take a look at this one. So 1, 2, 3. So we're matching at 1, excuse me, and then we're using the capital N. So then we're appending this to the pattern space. And so with this in the pattern space, we are substituting this. Actually, we are using this as a pattern and then nesting. And then the substitution will substitute 1 new line 2 with 1 space 2. You can match 3 or more lines with sed by just adding more and more capital N commands. So here we have Skippy, line 1 and line 2. Okay, and so we are matching on the Skippy pattern. Then we're using 2 capital N commands to read both of these lines into the pattern space. And so each one of these characters, one of these commands, will read 1 line into the pattern space. So 2 here, and now I'm using the the substitution command to substitute Skippy, its new lines, and any text that occurs around these new lines, and it will replace this with 3 lines deleted. In this final example, I'm going to clear the screen and let's take a look. So here we have pattern 1 matches this, and then we have a substitution command, and so this will substitute 1, 2 into 2. But in order to change 1 new line 2 into 2, we need to use 2 of these capital N commands to read both of these lines into the pattern space. Then when they're both into the pattern space, they can be referred to in the substitution command and then replaced with 2. So there we have it. I'm going to clear the screen, and let's talk about the capital D command. So that will delete up to the new line character while the current command is aborted and the first sed command is executed. So let me show you how that works. So 1 and 2. So I'm using the N command to append this to the pattern space. Okay, and so at pattern 1, so at pattern new line 0 or more of any character 2, I want to delete the line above that pattern. So delete will delete above the pattern. In other words, it deletes the first portion of the pattern space up to the new line character, leaving the rest of the pattern alone. while the D character will stop the current command and start the command cycle over again. Let me explain what the capital P command does. Works in somewhat the same way, but it will print the line above this pattern. Okay? Whereas the P command will literally print everything in the pattern space. Here's another example. So at pattern 1, I am using the capital N command to read this into the pattern space. And so from pattern 1, 0 or 1 of any character between 1 and 2, so the entire pattern is what I'm matching with this pattern. I am substituting that pattern for 1 space 2, and then I'm printing. Honestly, I don't need the capital P for this. I can use the lowercase p, and it works. So the order of operations is capital N and then either P or D. Okay, again, the equals command will output the address number of the match. So 1 is address 1, and then 2 is address 2. Let me clear the screen, replay that, and let's put the address number and the actual string on the same line. So here I'm making this all one chunk in the pattern space with the capital N, and then I'm substituting the new line character for space. There she is. So just appending this to the pattern space and then using sed to the substitution command to refer to the entire pattern space. Now here is something that's very interesting. So the tr command will translate or delete characters. So okay, so I have this MAC address and I have this string, and so this will put these two strings on separate lines. And now I'm using an equation here, so I'm using sed and then I'm using the y command to change this to a capital F, okay, for the first string, and then I'm just reading in the second string into the pattern space. Remember, these are separated by new lines by the tr command, and so then I'm just replacing the new line character with a space, and then this is converted and on the same line again. So very interesting, but it can be done more simply. Hold on a second. It can be done more simply with back references. Let me show you how that works. So I'm going to replace all of these forward slashes with underscores, and so the back reference here will match F, and then I'm substituting that with \U, which will capitalize the next character to it, and then the next character to it is the back reference to the group here. So that's uppercase F. So we're basically replacing lowercase f with uppercase F, while not touching these F's for Jeff. That's why I put them here. So a lesson back references are always very, very nice and fascinating. So let's check out this. We have A, X, and Y. Oh, sorry. Okay, so A, X, and Y, each on their own line. So at the end of X, we want to read that into the pattern space. And so X is separated from Y by a new line. So because from this pattern we are appending this line into the pattern space, we now have X and Y in the pattern space. And so we are saying at the new line at the end of the X string, separating it from Y will be replaced by nothing. So X new line is replaced by X, thus putting the X and the Y on the same line. Okay, so stay tuned for episode 12.